Two swimmers, Alan and Beth, start together at the same point on the bank of a wide stream that flows with a speed v. Both move at the same speed c, where c is greater than v relative to the water. Alan swims downstream a distance l, and then upstream the same distance. Beth swims so that her motion relative to the earth is perpendicular to the banks of the stream. She swims the distance l, and then back the same distance so that both swimmers return to the starting point. Which swimmer returns first? Okay, so this is how I solve the problem. First of all, we know that both of them are traveling a distance L, and they're both moving in a river. So let's say this is our river, moving to the right with the speed of v. And there are two people over here, A for Alan and B for Beth. So Alan's traveling a distance of L to the right, and then she's coming along the same path. And Beth's also traveling a distance L down, and then she's coming back. The only other information that we have over here is that both of these move with the speed of v. Sorry, the speed of c. So speed c relative to the velocity of the river. Now, first let's consider the motion of Alan. We know that the river is moving to the right with a speed of v. And we know that Alan is moving with a speed. So if we assume that this is a point of reference with respect to the river, Alan is moving with the speed of c. So v of Alan, speed of Alan, with respect to the earth, is going to be the speed of the river plus the speed of Alan with respect to the river. Now, to find the speed of Alan with respect to the earth, we already have both of these pieces of information. The velocity of the river is a constant, which is v, and Alan is moving with the speed of c with respect to the river. So her final velocity when moving downstream is v plus c. Now, when we look at Alan moving upstream, we know that the river's still moving in this direction. However, since Alan is moving to the left, so in this direction this time, her speed is acting in this direction. So this is v, and this is speed of Alan with respect to the river. Applying similar reasoning over here, we find that velocity of Alan with respect to the earth is going to be the velocity of the river with respect to the earth plus the velocity of Alan with respect to the river. Now in this case, the river is still moving to the right, so this is still going to be a positive v. However, in this case, Alan's velocity is moving to the left, so c over here becomes negative. Thus, her final velocity is going to be v minus c. To find the total time she takes to travel this distance, all we have to do now is divide the first distance L, so t1, during the first part of her motion to the right is going to be L divided by v plus c, and t2 is going to be the time for her second part of the motion when she's coming back. That's going to be negative L over v minus c, which is the same thing as L over c minus v. If we add both of these times together, we get t total is equal to L over v plus c plus L over C minus V. Now just solving, like combining the denominator, we find that, the total time she takes to be equal to 2LC over C squared minus V squared. Now we can apply similar reasoning for Beth. We already know that Beth is moving straight up relative to the ground. So let's just say this is ground. So, and this is her velocity relative to the earth. Now, over here, the velocity of the river is to the right. And we know that her velocity with respect to the river is c. To solve this system, we can use the fact that velocity of Beth with respect to the earth is going to be the velocity of the river plus the velocity of Beth with respect to the river. In this case, from the diagram I set up over here, we already know that her velocity with respect to the river is c. The velocity of the river is v. And thus, to find this part right over here, we can use the Pythagorean equation. And this diagram comes straight from this equation, because all of these are vectors. So if you're adding v sub r plus v br, you get v with respect to earth. Now to find v with respect to earth, you just apply the Pythagorean theorem, and you get that it's equal to v br squared minus vr squared, which is the same thing as c squared minus v squared. Now we don't specifically need to form two separate equations in this case, because even when she's going down, the only thing that's going to change is that her speed's going to go down like this. Velocity of the river is still going like that, and in this case, her speed is going in that direction. Though it's negative, it's going to cancel with the fact that the distance she's traveling is also in this direction, rather than moving up like in the first part. Now to find the total time taken by Beth, we again use two separate cases. So T1 is equal to L divided by the velocity that she travels distance by. So c squared minus v squared. And T2 is just going to be negative L over negative c squared minus v squared. Now if we add both of these equations, we get that the total time is equal to 2L divided by the total time is equal to 2L divided by c squared minus v squared. Now, if we reformat this equation a little bit by multiplying by c squared, square root of c squared minus v squared on both the denominator and the numerator, we find that it's equal to 2L square root of c squared minus v squared divided by c squared minus v squared. Now if we compare this equation to the one that we got for Alan, which is 2LC over c squared minus v squared, we can see that this part of the equation is the same as this part of the equation for Beth. So to find the difference between the time, we just need to compare c to the square root of c squared minus v